So I like to put these steps from the book in my own words, and the stuff that you struggle with, I recommend you use your own words. For rounding, I like to locate my rounding digit by using an arrow. So for example, on that worksheet, all of them did hundredths, and they did hundredths on purpose because we're most used to dealing with money, and that hundredths happens to be just like pennies. So on every single one of these, I would have put an arrow on all the hundredths places. And that's called my rounding digit. So I'll write one of them on my talking pen here. We'll do 3.2884. So what I've done so far is put an arrow on it. And then next it says locate the test digit directly to the right. And what I like to do, and this is not required, but what I like to do is I like to underline the test digit. I found that this helps students over the years to have an arrow on where you're rounding at and an underline on what you're looking at. You might like to box in the text digit. I've seen that happen before. And then they put, if the test digit is 5 or greater, round up. And what that means is the more important thing. If it's 5 or greater, round up means that we add 1 to the rounding digit. And that is the situation that we're currently in. The rounding digit is bigger than 5. And so we round up to make it 9. And then my Math 60 students liked this class's analogy that you add the bacon symbol that reads approximately equal to.
Hey, you said you liked it though.
I did too. The problem is once you say it and see it, you can never think about it as anything else. So that's rounded, the nearest penny. So you had a whole bunch of them to do to the nearest penny. You can zoom in a little bit so you're squinting. And then the more important one to be careful of is if the test digit is 0, 1, 2, 3, or 4, so it's less than 5. Read what the book says carefully. I'll write it down. If the test digit is less than 5, round down. Okay. But here's the kicker. Oh, you can't really even see it. By keeping the rounding digit and dropping all the digits to the right. Rounding down means keeping it. It doesn't really mean moving it down. We don't subtract one from it. We keep the rounding digit.
There's no numbers to look at. 0.9.
Yeah, I'm going to show some of those. There's some weird ones in there. So keep the rounding digit. So the example of that might be the second one where it's 4.0529. And by the way, it's a good idea to practice reading some of these. This would be 4 and 529 tenths, hundreds, thousands, 10 thousandths. See it? Tenths, hundredths, thousands, 10 thousandths. So it's 4 and 529 10 thousandths. But we're going to make it easier to say. because they wanted us to round to the hundredths, so I put an arrow on the hundredth, underline my test digit, and what does my test digit say to do this time? So that's keeping it the same. So that's the nearest penny or the nearest hundredth. And now I would say it is 4 and 5 hundredths. So that rounding digit will be part of my vocabulary. There, to this one from the activity, 1.6929. My rounding digit is the 9. My test digit's the 2. That's not the one I meant to do. But whatever, we'll finish it up since it's here. Do I round up or keep it the same? Notice how I said that. I never say the word round down. I just say round up or keep it the same. Once I got my arrow on it, that might help you. And do this one here, 1.5046. Maybe practicing saying these out loud every once in a while. That's 1 and 5,046 10,000ths. But again, we're going to make that easier to say. There's my rounding digit. It happens to be 0 this time. There's my test digit. Keep it the same. In your answer key, they rounded that to 1.5, and they're wrong. You really should keep the 0. It doesn't mean any difference to a math teacher or a math program, but in some of your, like in accounting, it would look weird to get rid of the pennies if you rounded to the nearest penny. In a science class, if you round to the nearest hundredth, you keep the 0 to show you where you rounded to. So we're not really talking about significant digits in here and what all that means. That all happens in your science or engineering or other classes, but I shouldn't give you bad info. All those ones where they didn't put the 0, they should have.
What about that 0.9?
But then there's this one weird one. We wanted to round to the hundredths, and it was 0.9. That one wasn't, in terms of engineering or science, it wasn't accurate enough to begin with to even round it. So it's like a trick question. Nothing can be done. So if it doesn't have a digit in the location that we want there to be a digit, they're actually right that you just keep it at 0.9 on that. That's nothing to do with math. That's about significance. So this one would have a significance in the tenths place. We couldn't suddenly create significance in the hundredths by putting a 0. So what am I worrying about? If you say 1.5, I'm happy. I might throw in the 0 for you just to remind you. But I wanted to make sure my answer key was correct.
You're going to throw trick questions on your test?
No, there's no reason to throw that one on.
For those of us that get going on how we think it's done, and then a nice comment if it's not.
So I'm going to throw some down to give you a couple minutes to practice. Let's switch it up just a little bit. And for these practice ones, I want you to round to the nearest thousandths place. So, thousandth place, before you really can get much of anywhere in this chapter, remember on page 317, you got to remember the different names. And in particular, I'm pretty good with my whole numbers, ones, tens, hundreds, thousands, 10,000s. I've had more practice with that. So the way I think about it is there's no ones place to the right of the decimal. This starts right on the tenths, but it's the tens with a TH, and it's 100 with a TH, and 1,000 with a TH. And a TH is important. And it's here. Because it would have been something entirely different if I said round to the thousands. And we're going to actually practice that here in a second, where I ask you to round to different values. So on all of these, because of the TH, our arrow, and if you missed any of these, I'm going to highly suggest you start putting the arrow as a stepping stone to be able to get to these stuff. And that's actually, I can give you partial credit. The student now, I know that they know where the arrow is, so they know where they're rounding at, so they got some partial credit. And so, there's a MTH digit. What happens to the 8? And see if you put your bacon symbols.
So we used to do the equal sign now.
Yeah. I'm probably going to get the best or the highest percentage of people doing approximately this term because of the bacon symbol analogy. But that said, if you put equal signs, just start remembering and start working on, I'm not going to take off points for the equal signs. And it means approximately equal to. Jackson. Yeah. Is it about that or about, what's your question? Or do you have a question?
No. No, I'm good.
So what happens to the 4? The 3 right beside it says it stays the same. And what that means to me, another way to think about it, is all that stuff didn't change any. It just lopped off the extra stuff because the extra stuff was too small. And we looked a little bit at why that happened on Tuesday. Today we're just treating it like a rule, and this is how you round. And here's a tricker. So 7 saying turn my test digit up, add 1 to my test digit. What's that going to look like? You're going to get 300 there. So he went all the way out and thought about it as 299 going up 1 to become 300. And officially, and this again is more related to what you'll see in science classes, they would really prefer if you keep the 300 with all zeros right up to where it said. Because the way I'd read this now is 15 and 300 thousandths. So I still say the word that I rounded it to. If you just said 15.3, you're fine. But I just want you to know it'd be preferred to say 15 and 300 thousandths. Heck, you read wrong, too. Anyway, we'll not get into that. Yes, no trickery in that one. So we're going to try some more practice ones. And the way I'm going to switch it up a little bit this time is I'm going to, on each problem, pick a different place I want you to round it just for practice. So I'm going to flip my paper. Is everybody done with that page?
Are we turning in then?
No. Just goes in your notes. If I forget the answers to them, I won't look at your paper. I'll go back and watch my Livescribe pen again.
Yeah, I'm doing good so far, so it's a good thing.
Are those all visible? Okay, we get started. This will be more like it looks like on an exam where you have a section where you do some tenths, section where you do some ones, section where you do some thousandths, etc. with quite a few problems on there to practice. Really, nines are the only challenge once you get this arrow and underline. Because nines, when I send a 9 up, I got to be careful. So I'm sending a 9 to make it larger this time because the 6 is telling me to make it larger. How I think about it doesn't mean that it has to be how you think about it. I just go across the decimal and think about 39. What would happen to 39 if I added 1 to it? 40. Some people I've seen, it's kind of like the book adds 1 and then they carry it over or something along that line, some record keeping. I just think about it as 39. I find that easier. So this would be 244. And again, it would be good have it to keep the 0 where we rounded it to. This would probably be the most likely one for somebody not to put the 0 out of all of them. And that makes sense to me. It's not my big worry. But it's a good habit to leave it. The questions on that one? Nothing happened here. The test digit says leave it alone. I'll move that up if everybody's okay. The ones place isn't always called the ones place. The ones place is sometimes called the nearest whole number. The ones place is sometimes, if it's money, called the nearest what? It's sometimes called the units place. I don't hear that one as much. So ones, whole number, nearest dollar. I'll just think if I remember any other ones. But those seem like the common ones. And then I'm saying send it up. So what does it become?
40. Drop the decimal.
Yep. Most of us would drop the decimal. There's actually nothing mathematically wrong, as far as I know, to keep the decimal because it's there. It's just pretend. But most of us don't put a decimal when we're talking a whole number. So the nearest whole number has that ability to get rid of the decimal. Okay. I think you're doing better than usual on this. That's great. Some classes really struggle with this. Walking around looks like you're doing pretty good. That says send it up. So it goes up to 9. And finally, this one, last one, had a whole bunch of zeros to be careful about. And so the thousandths has my arrow there, and of course it was designed to be hard so that you would have to go up. The way I look at it is what happens when I take 2,999 and add 1 to it. 3,000. And I keep all those unnecessary zeros, especially if I'm in science class. Let me show you how the book deals with 9. I swear I just saw something interesting. Yeah. Yeah, it's not that exciting. They do the same thing I do. Never mind. Sidetrack. I'll give you one last example of rounding. It's not that small actually, but you're driving by a town and it has 32,451 people. They don't usually make signs that go right up to the nearest person for their population sign. It'd be kind of silly. So they either, depending on the size of their town, they have to round. A possibility on this one would be to round to the hundredths place. And the reason I'm bringing this up is there's no TH. And if there's no TH, where's the near hundreds place? Agree? It's a 4. That's a comma, right? If you thought it was a decimal, I don't know what kind of town you're going to. So it's got 32,451 people. None of our examples so far have shown this. Theoretically, it's supposed to be a review, but I don't think everybody walks in here know how to run round. So, I don't know. Questions? Hundreds? Without the TH? That rounds up. And this is actually harder than rounding decimals, because when I round that up to 5, with decimals I just lop everything off and I'm done. You gotta add zeros with whole numbers. Here's how I always explain it. Instead of thinking about adding zeros or lopping off zeros, if I'm going to round to the hundreds place, when I read the word out loud, I should have the word hundreds in the reading of the word out loud. This has now become 32,500. The last thing I say is the word hundred. This one's kind of a trick, never mind, but officially this is 3 and 0 thousandths. Now all the other ones, is that tenths? 244 and 0 tenths. 32,427 and 8 tenths. I can say the word I rounded to is my last. So that's how I always explained it. We had to throw some zeros in there to make it still say 500. Would you want to practice a couple of those or move on? We don't have much time. Practice a couple. Let's just do a couple. So let's do a couple to the hundreds. And I'll move that up. And let's do a couple to the thousands. Notice no THs. I don't have as much time as I'd like today. So for the 200s examples, my arrow should be on the hundreds. Again, especially if you're struggling, go ahead and put those arrows because I can give this student partial credit. They know where hundreds is, right? And so the 5 says to go up to 3. So that's the same, but what's new? What do I have to do? And I can stop, even though it used to have in 20 cents, let's say. I can stop with my answer without any decimals. I just needed the 2 zeros to make it so that it read as 4,300, so that I said the word 100 as my last sentence. And this one would be 4,000? And that would be one of the few exceptions. It's because there was a 9 involved. I rounded it nearest 100, but I didn't have any hundreds to say. It was 4 and 0 hundreds. 4,000 and 0 hundreds. It's just 4,000, but it's rounded correctly. Thousands is there.
I thought it was on the pages.
Let me show you. Just because on the it's 4 over from the decimal.
Oh, it is. So I was counting. I was counting.
Pretty common actually on thousands to not count more than enough. So if we see it there, it's 4 over. And just something to work on memorizing. So I think I have my arrows right. And so this one's saying kick it up to 5,000. Again, you don't have to include all those things there. There's extra things that filled up your calculator when you were doing some calculation. And they were too specific, and so we made them go away. And this one also wanted us to go up. How does 19 go up? Okay. This has all been the first section, 3-1 or 4-1. I want to go into 4-2. In just a second, I want to give you one quick reminder in 4-1. If you're using greater than and less than symbols, and you're comparing with greater than and less than symbols, a couple of things. There was a nice trick that we learned, yeah. Yeah, we're not even going that far. And I don't think I put that up there. I think this is all I said on it. But yeah, this is as far. This is plenty actually. So this is with rounding, adding, subtracting, and multiplying. And then the next one would be division. We'll talk about that next week. You may remember what the trick was on greater than or less than? Yeah. There wasn't a 0 there, and the trick is to make them both be the same accuracy, same number. Not digits, it's the same place value. So add zeros to make them both have the same place value. That's the trick. It's optional, but it sure helps. Who's Pac-Man gonna eat? Yeah. Officially, there are other ways to do this. Pac-Man's eating the 3-5 because the 5's bigger the first time, but if you make them have the same digits, that usually helps. So I need to move on. So we're going to look at section 4-2, which is adding and subtracting. first example in 4.2, depending on your scenario, will either give you nightmares or maybe you'll get a refund. I don't know. But there's their first example. Some of you, when you do your taxes, round to the nearest dollar. And if I remember right, it's actually perfectly legal and just fine. You just can round it to the nearest dollar. And then others, when they do their taxes, I remember the old taxes you really had to be more careful on. They used to come with a little line, and you put your pennies on the line. And maybe some, I think that's true. In any case, here's the kicker here. For the 200, they added a couple of zeros, and they lined up their decimal places. For adding, it's really all there is to this section. When you're adding or subtracting decimals, you line up your decimal places, and you put some zeros in if necessary. So, for example, I'm just going to give you a couple examples. If I wanted to do 3.42, so 3 and 42 hundredths, and 2.893, or 2 and 893 thousandths, real similar to how the book was doing their taxes there. I'm going to line them up. And then what? So I had to add that zero right there, and then I'm ready. So 3, 11, 13, 6. I think it's almost intuitive what to do with the decimal. Bring it down. And did I mess up or am I good? 3, 11. Yeah, I think fine. Okay. And then in my second example, I'm going to take 15 and subtract from it $3.86. Taking money. How do I line up the decimals?
The $15
Does that make sense? And that was similar again to that tax example where with the $200 one, it's right at the start of chapter 330. So on page 330 with the tax example, instead of just throwing in $200 there, they put 200 and they included their zeros just for kind of a placeholder. And that wasn't very important because they were probably just adding on the tax thing. But on ours, when we're subtracting, I really need those zeros. Because then it gives me, I'm going to borrow all the way across. So that's going to become a 4. That's going to become a 9, and that's going to become a 10. Questions on not borrowing?
11 plus 14.
Oh, yeah. 10 minus 6 is 14. 4.
10 minus 6 is 4.
9 minus 8 is 1. Minus 3 is 7, bring to 1. If you tend to make mistakes with subtraction, how could I, this is a good example to think about it, how could I check if I got that?
Yeah, the bottom one, see your answer.
Check. This is optional, but this would be a pretty easy one to do a mental error. And so I went ahead and added back on that amount that I'd spent, and I got back to $15, so we're good. Okay. Life would be just fine, I think, if that was all that was in there. But then they throw sign numbers at you, positive and negative. So can I move that up?
Yep.
Good. And it's the same rules. You just need more practice with them. And it's good because there's quite a bit in here. So there's going to be the same sign number rules. So for adding, if they're friends, and they're both negative in this case, so they are friends, what do I do with them? So for same sign, we add and keep the sign. Or for my analogy, for friends, we put them together and they stay friends. So 8.6. And it's negative because they went together to be negative 8.6. So that was adding. Question on that one? Yes.
I have a question. So like on 47, negative 4.49, subtract negative 11.3. You don't do change that? Or no?
I'm just going to do a similar one and let you think about it, Brian. But here's a similar problem. And that similar problem involves subtraction. And my recommendation is to always, don't do subtraction. So that you can see it at home when people look at this. One way to explain this is with that change. And that would look like slash. I changed two things that were right next to each other. Or I changed the subtracting to adding the opposite is the real words that go with it. And if you do that and get rid of your subtractions, you only have to memorize the addition rules, and they're way easier. So those friends are enemies. So that one's negative. And that one is positive. That's the switch. So now they're unlike signs or enemies. So the directions were subtract the magnitudes. And what that would look like would be 8.3 minus 2.1 is, I think, 6.2. No. And then 6.2, how do we decide if it's positive or negative 6.2? And there's some harder ones in your homework than this, but those two examples we got here, pretty good examples in terms of, that means it's just good sign number practice, not too hefty. Yeah, Daryl?
That's a negative 6.2, isn't it?
Yeah. And it's there. So this is my actual answer over here, and this, and that was my process or my scratch work. Yeah. I don't have tons of time to do specific problems, but I will. That's what we do on Monday. I can look at it real quick. 53. Yeah, let me get to that. I want to do some multiply before we look at order of operations. It is on my list to do some stuff like that. So I wrote it wrong. It's 4.3 that's multiplying decimals. And in the book, right at the start of 4.3 on page 344 gives us some directions. Okay. The directions are quite a bit different than add and subtract. That's the important thing. 344. So for multiplying, you don't line up the decimals. For multiplying, you multiply them like they were normal. You count how many decimals there were, and you insert a decimal point in the result from step 1, so the answer is blah, blah, blah. So let's put that in our own words with an example. 1.5, I'll fix that just a sec. Would represent time and a half. So if I worked overtime, 1.5 is kind of like time and a half because I'm getting my full amount of pay. And suppose my normal pay was $9.75 per hour. And I just happen to possibly not have a cell phone. Maybe I can't take cell phones to work. So along that lines, I don't have a calculator anywhere. First of all, I'll give you a warning or a thing. Some of your multiply problems in your homework might be kind of long. I just want you to know the process for multiplying. If it's a very hard multiplication problem, I'm going to grab my calculator. All right. I can add and subtract all day long, but I'm not going to do a huge multiplication without my calculator. So this is a good sample of kind of the size of a problem I might want to do. If I could do this one, I'm pretty golden. All right, so let's see if we can figure out the overtime pay. So everybody see our goal? Do we want to add, subtract, multiply, divide? Most of us would probably write the bigger number up top and put the smaller number as what I multiply by, because it doesn't matter what order you put them in for multiply. And then, unlike adding or subtracting, just fuzz out on the decimals. They don't exist. So what I'm seeing for the moment in my head, this is just in my head, I'm going to leave the decimals officially, but in my head I'm thinking about that for now. I'm not even worried about decimals. So 5 times 5 is 25, 5 times 7 is 35, 36, 37. 5 times 9 is 45, 46, 47, 48. I always mess up if I don't kill off my carries from the previous one. Throw in a 0. Oh, and actually there won't be any carrying this time because it's just times 1. 5, 7, 9. Add them up. 1, 2, 3, 4, 5, 14. And I'm doing this particular problem first. Do you think I make $146.25 on time and a half pay per hour?
$14.
Trisha's saying the decimal probably should go there, that it's $14 and some change. And the reason, based on the directions, is you count the number of places after the decimal in both numbers. So in this case, how many places are there after the decimal in both numbers? 3. And move the decimal back that same amount of space. Move the decimal back 3 spaces. Sorry. So count the number of places after the decimal in both numbers. Move the decimal back or to the left. And then I believe Trish was telling us that since this problem was about money, it's implied that we should probably do one more thing with our answer. I did round it and then include per hour. There's actually 2 things we need to do. So since I'd like to get the pennies as well every hour, I would like to round it to the pennies, to the 100th. And in my favor, sweet, it's going to go up. Yeah, and then excellent. Daryl wanted us to label it. We should always try to label our story problems. Yeah. So I could see having to do that somewhere. What?
Overtime, because that's what we make overtime. So do I make
And then we would say it as a sentence. Don't forget your bacon.
Bring home bacon.
And you won't find me writing a sentence for every story problem, but it's really not a bad idea, and it'll make your future teachers happy. So, in my limited amount of time, I want to show you a couple of other things. Then we'll take pretty soon a quick break and then the quiz. So these are going to go pretty fast. The first one is there's a few problems in your homework that have exponents. Okay. They didn't look too bad. As in, they didn't have too many decimals involved. But that says 1.4 squared. It's just, in a lot of ways, just a good review. What square means. You multiply it by itself. At that point, if it's about that size, I keep my calculator away and do it by hand. If it's much bigger, I might pull out my calculator. We're getting close to calculator time. I think it's chapter 5 where... So even some of these in this chapter I'm going to pull out my calculator on, but not this one. I could do this. Maybe. Because it's a good skill to know that how many places do I move my decimal over? 2. 1, 2. It's 1.96. Questions on that one? Then there's also some signed numbers in your homework about multiply. Those are a little easier than the add ones. So if you got 3.4 times -2, is that positive or negative? And a lot of them you might be able to do in your head. That's -6.8. If I had to, though, I would just write it out. And then how did I figure out where the decimal went? Yeah, over 1. That's why it was -6.8. Could anybody do... Man, this one's looking ugly. What do you think? We're multiplying. Positive or negative, first of all? This is page 347. To find the product of a decimal in 10, 100, 1,000, and so forth, move the decimal point to the right the same number of places as the number of zeros in the power of 10. I don't like that explanation, but I'm going to put it in my own words. How many zeros does 100 have? Excellent. I'm going to move the same number of places over on the decimal to make it bigger. This is positive 342.06. It's positive for my signed number rules, and I was able to do it in my head because of the trick with 100. If it was 1,000, how many zeros does 1,000 have? 3. There's going to be 3 moves. So think about that. There's a couple that use... you can do the same thing when you multiply by 0.1 for 10% and 0.01 for 1%. I don't use that trick as often. So this is good. And then my very last thing. You're going to hit, in this week's homework, some order of operations. Okay. They're going to look like I don't remember which of these is actually in your homework, but where's my finger? There's one, number 81.
What page is it?
It doesn't matter.
Oh, okay.
Okay. I want you to give it a try. But you got to follow order of operations just like before. An order of operations said parentheses, exponents, multiply, divide, add, and subtract. So on 81, I'm not sure if you can see it very well right there. But on 81, it has an exponent, so that's where you'd start. So don't ever spend more than a couple minutes on these. If one catches you, slow down. And then I know that... I'm trying to say, if one catches you off guard, just mark it. And I know, for example, in 4.2, there's also some order of operation problems. An example is the one that Melita was asking. So I'm not going to actually do it, but I'll talk you through it a little bit. On this one, there's some parentheses. And so we're going to work those parentheses first. And in those parentheses, they're enemies. And so we're going to subtract. When you get done with those parentheses, you're going to have an answer. And I can't really actually do it in my head very well, so you can. But the answer is going to be negative. And then we have a subtract, a negative. And that example that was shown Brian, when you have a subtract, a negative, whatever that number is, when you get there, you should change. So I would like everybody to try that, and we'll talk about that one again next week.